All right, so this section is called limits involving infinity. So basically, it's going to be about vertical and horizontal asymptotes. So I know that you guys have talked about vertical and horizontal asymptotes before, but this is going to go a little bit deeper into our understanding of how they work and how they're related to limits. Okay, so vertical asymptotes, as you know, are vertical lines that graphs get closer and closer to but never cross. A vertical asymptote occurs when the rational function or fraction has a denominator equal to 0. So if you have f of x over g of x, it's just setting g of x equal to 0. But sometimes, right, sometimes it's not when the denominator equals 0. Sometimes if you factor the numerator and denominator, you'll remove part of it, like x minus 2 and x minus 2. And then that means that you had a hole of 2, right? So sometimes it looks like it's going to be a vertical asymptote, but it's really a hole. Okay, so number 1. So it says determine all vertical asymptotes of the graph of each function. So the very first one, if we set our denominator equal to 0. Oh my goodness gracious. I really did draw that tiny. Hang on. Let me pause. All right, let's try this again. So anyway, so if I have 4 times x minus 2 equals 0, then we get a vertical asymptote at x equals 2. Now in this section, I'll be asking you specific things about the limit as x goes to 2 from the right and as it goes to 2 from the left. And you're going to have to use some of your knowledge from transformations. Remember shifting left, shifting right, all of that. So this graph has a parent function of 1 over x. And 1 over x is the one that looks like this, right? So this one doesn't look exactly like 1 over x. It's been shifted to the right 2. That is why the vertical asymptote is at 2. Right? But the rest of it does look like 1 over x. It just has a 1/4 there as well, which is kind of doing a vertical compression, smushing it down. So our graph looks something like that. So you're going along the vertical asymptote in both directions. So if I asked you something like, what is the limit as x goes to 2 from the right of the function, what do you think that we would write? We would write infinity, because as we go from the right, we're going towards infinity. But if I said, what is the limit as x goes to 2 from the left of f of x? That would be negative infinity, exactly. So we'll be talking about infinity and negative infinity in approaching those things. So g of x, for this one, we would say x plus 3, and we'd have x minus 3. So we get x equals negative 3 and x equals 3. Okay, it didn't factor on the numerator because I had x squared plus 9. Which does not factor into x plus 3 times x plus 3, so there's no hole there. That's it. And then tangent of x, we mentioned this briefly the other day. The graph of tangent of x looks kind of like the cubic function, like y equals x cubed. But it has an asymptote at every, we start at pi over 2, and then we add pi to it, so 3 pi over 2, and so on. So the vertical asymptotes for this would be pi over 2, 3 pi over 2, 5 pi over 2, but we'd also have negative pi over 2, negative 3 pi over 2, and so on. So in pre-calc, remember, we didn't like to write things out like that. It was a lot of writing. So does anybody remember how we would write that? Nick, do you know? It's really close. So we're going to have pi over 2, but it's not going to be 2 pi because tangent has a period of pi. So we'd say plus pi k or plus pi n if you use n for an integer. I always use k, so where k is an integer. So it means if I add 1 pi, 2 pi, 3 pi, 4 pi, or negative 1 pi, negative 2 pi, I get other answers as well. So those are going to be the vertical asymptotes for that one. All right, so the next one, so it says find all vertical asymptotes of the graph. So this is one that looks like maybe it does factor in the numerator and denominator. Maybe there's something that cancels, right? So we go ahead and we factor. And when we factor the top, we see we have x plus 4 and x minus 3. And on the bottom, I have x plus 3 and x minus 3. So we can see that the x minus 3's do cancel. So that is not a vertical asymptote then. That means that there is a hole at x equals 3. So when we look at the simplified function, our simplified function is x plus 4 all over x plus 3. We can find the vertical asymptote and even the horizontal asymptote from that. So if we just have y equals x plus 4 over x plus 3, what is the vertical asymptote? X equals negative 3, exactly. What is the horizontal one? Y equals, close, not 4/3 though. It'd be, take your largest degree from the numerator and denominator. This one over this one? Yep, so it's 1, exactly. And we'll talk about the shortcut in just a second. So if I was sketching this out, and we did this in Algebra 2, and you guys all hated this section, it was section 9.3. It's the worst. Yes, Sissy?
Oh, yeah. Why would there be a hole?
There's a hole because we canceled the thing that was in the top and the bottom. So it's not a vertical asymptote, it's just a point that's not really there. Did you guys remember 9.3? Did you remember?
No. Nope.
All right, and then y equals 1. All right, and once you get the vertical and horizontal asymptotes drawn in, a lot of times I would just have you pick points. So this one is either going to go like this, it's going to go like this, or it's going to go like this. Any guesses? 1, 2, or 3? What do you think it's going to do? It's going to do like 1, right? It's going to be like 1. Because there's no negative, that means that it's flipped over the x-axis or anything. But basically, if I plug in, let's say 0 into the simplified version, this y equals x plus 4 over x plus 3, what happens when I plug in 0? I get 4/3. And 4/3 is above 1. So because of that, it's going to be above the horizontal asymptote and go along the vertical. And then if I plug in like -4, then I get 0. So that one's going to go there. But really, I can tell already what it's going to look like because I know that there's no negative x, which means it would flip over the x-axis, yeah. Like if I had negative x plus 4 on the top, there's some kind of reflection. Okay, so then the last thing is that there's a hole right there. So that's what the graph looks like. So if I asked you, what is the limit as x goes to 3 from the right side, what would we put? X goes to, sorry, -3 from the right side. Are you like, what? I could have done 3 as well, though. So limit as x goes to 3, dang it, I keep doing 3. -3 from the right. It would be infinity, right? So I noticed a lot of you guys on your homework keep leaving off the function. Like you can't have the limit without some kind of function there. So limit as x goes to -3 from the right is going to be infinity. And then from the left would be -infinity. If I just talk about 3 in general, the number 3, not -3, what's that limit? What y value did it get closer and closer to? Well, just plug into the simplified version. What happens when you plug in 3? You get 7/6. That would be the y value it would go towards. Okay. So the next one, so it says find the limit as x goes to 4 from the right of x squared minus 9x all over x minus 4. And the limit from the left using a graphing calculator. So let's go ahead and put this into our graphing calculator. So you can get yours out. If you need some, I think I should have some somewhere. Maybe on my desk. So when I graph it, it looks kind of like that. Kind of hard to see what's going on here. You can zoom out if you want to. So you can hit zoom and then zoom out and hit enter. Now you can see it a little bit more exaggerated. Okay, so there's a vertical asymptote and there's also what we call a slant asymptote. I see lots of faces. All right, a slant asymptote, you're not going to be asked to find it by hand or anything. You're not going to be asked to graph anything like this on the AP Calc test, so don't worry about it. Just kind of remember what that is. So it's a line that you're kind of going along, a slanted line, right? And then we also have the vertical asymptote as well. All right, so when we talk about the limit as x goes towards 4 from the, what's the first one, from the right? Oops. What's it going to be? So 4 from the right, -infinity, right? And then 4 from the left, positive infinity. So this one's going to go towards -infinity, and this one's going to go towards positive infinity. All right. So you could also do that with like a table of values. You could take values that are getting closer to 4 from the right. So you could plug in like 4.5, 4.1, 4.01, right? And see what you would get towards, and your y values would get larger and larger. All right, so those are vertical asymptotes. So it says we found vertical asymptotes by setting denominators equal to 0. Horizontal asymptotes are the y values our graph approaches on the ends of the graph. Okay, so basically they're limits. They're limits as x goes to infinity and as x goes to negative infinity. Every single time you see a problem in the AP test that says horizontal asymptote, I want you to think of both of those. So you have to think infinity and negative infinity. Elena, you with me? All right, so you're going to both infinity and negative infinity. So there's a shortcut to find horizontal asymptotes, which I've taught you. And this is great for most of them, except for the ones where previously, like in Algebra 2, we just said there is no horizontal asymptote. Right, do you remember the ones where it ended up being no horizontal asymptote? It's when you had like a bigger degree on top than you have on the bottom, maybe squared. Right, when that happened, I just had you write no horizontal asymptote. Well, now we're going to be more specific with these things. Okay, so now we're going to say it goes to infinity or negative infinity or whatever. Okay, so I'm going to show you the long way, and then we're going to discuss the shortcut, and we'll continue kind of talking about a shortcut method for finding these. So here's the long way. All right, the long way would be saying, okay, I'm going to take the limit as x goes to infinity, and my highest degree is x cubed. So I'm going to take every single item that I have here, and I'm going to divide every single term by x cubed. It's annoying to write out, I know. So as we're doing that, we now simplify and we say, okay, x cubed over x cubed, well, that's 1. 8x over x cubed is 8 over x squared. And then 2 minus 1 over x plus 7 over x cubed. Okay, so we have this. And now we know with our limit laws, we can bring a limit into the numerator and the denominator. So I could do limit on top and bottom. And then I can bring limits into the sum. So what I'm really doing is I'm finding the limit of this one, the limit of this one, the limit of this one, and this one. Finding the limit of each individual thing. So I always use a really sick analogy. I'm going to use it just because people remember it. I don't care. Whenever we talk about fractions, like when you were in elementary school, you always talked about, oh, if I have 1/2, if I have a pizza, I'm going to divide by 2 people, and that represents 1/2, right? 1 out of 2. And then you're like, okay, well, what if I have this pizza and I divide it by 4 people, right? And then I have 1/4, fourth of the pizza. All right, what if you have a pizza and you divide by 10 billion people? How much pizza do you have? You really don't have much. It's like you're licking the piece of pizza, or the pizza, and passing it on to 10 billion people. Please don't ever do that. That sounds disgusting. Right? You don't get anything. There's nothing there. It's not making you any less hungry, right? You're not eating anything. So that's what's happening when you have a big number on the denominator. So when you say the limit as x goes to infinity, this one, 8 over x squared. 8 over a huge number squared is even bigger, right? 8 over a huge, huge number. What is it? 0, right? So this goes to 0. We do a little arrow, and we put goes to 0 for each of those. So what's our answer? 1/2. Did you all know it was going to be 1/2? Yes, because I've taught you the shortcut method before. So the shortcut method is you just take your highest degree on the top and bottom, and you ignore everything else. It's like these other things are totally gone, because compared to the infinity cubed, just a regular infinity is worthless. Infinity cubed is so much larger than just regular infinity. It doesn't matter because of what I just showed you, dividing out, right? So what we end up doing is x cubed over 2x cubed, and we end up getting 1/2. Isn't that so much easier? So much easier, right? But like I said, they are going to be a little bit weird when they go to infinity. All right, so the next one, limit as x goes to infinity of x squared plus 4 all over 6 minus x. All right, so this one would be, in Algebra 2, you would say, oh, my biggest degree is x squared, and I have 0x squared on the bottom, so I have 1x squared over 0x squared. And you'd say, no horizontal asymptote. Okay, but I want you to be even better than that. I want you to tell me what's happening on the ends of the graph. So I want you to find both the limit as x goes to infinity, and we're also going to find the limit as x goes to negative infinity. So when you see that you have no horizontal asymptote, what that means is the ends of your graph are either going up, going down, doing something like that. Right. Pay attention. So we have to figure out, there's no square there, is there? So we have to figure out what it's doing. I know. Oh, so close. Yeah, you missed it. All right, so we have to think about what's happening with this graph. And what we do, instead of looking at only the biggest degree x squared, we look at the biggest degree on the top and on the bottom. So I look at x squared and I look at the negative x. Biggest thing on top is x squared, biggest thing on the bottom is x to the first. And you can even write those and you can reduce it and you can say, okay, well that's going to be negative x, right? So what happens if you plug a really, really big number into negative x? It becomes negative infinity, right? That's our answer. So this one becomes negative infinity. So what you can think to yourself is you have the big number squared, really huge number, and you're dividing on the bottom by a really huge number, right? Negative x. That's also a big number. But which one's bigger? The top or the bottom? The top. So when the top is bigger, it ends up being an infinite limit. It goes to infinity. Do you guys understand? And that's something like every year I have people in my calc class fight me on. They're like, infinity divided by infinity has to be 1. Like, it depends on how big the infinity is. Isn't that annoying? It's like the classic argument that you had with your siblings. I know, like, my brother and I did not get along. We're twins. When we were in school, we hated each other, and we'd always be like, I hate you times infinity, I hate you times infinity times infinity, right? There's no end to the argument, but there are different sizes of infinity, right? So it's confusing. Elena.
So do you want us to write the negative infinity?
I want you to say negative infinity, yep. And I also want you, so this one didn't ask for both, but when you're finding horizontal asymptotes, you have to do both. So you should do the other one as well. So let's think about this. So imagine plugging in a really, really big negative number. When you take the negative number and you square it, it's now positive, but it's really huge now, right, because it's been squared. Divided by 6 minus a negative number, what does the bottom become, positive or negative? Positive. What do you think this answer is going to be? It is positive infinity. So you can go back to what we had here, which was the x squared over negative x is negative x, and just say, oh, if I plug in a big negative number, negative infinity is going to be infinity. So this should be infinity. So this is basically just like end behavior that we talked about in Algebra 2. So when I said things like, as x goes to infinity, y goes to negative infinity, that's what we're doing. As x goes to infinity, y goes to negative infinity. All right, so this next one. So we have the limit as x goes to negative infinity. So we'll do both. We'll do infinity and negative infinity. So let's start with the negative infinity. Any guesses as to what this one's going to be? Infinity or negative infinity? The negative. So if I say limit as x goes to negative infinity. I don't know. It is infinity. All right. Right, because the x squared divided by 4x, that's going to go to x over 4, which is fine. But if I plug in a negative, it is negative infinity. What was I talking about?
I was right.
I confused you. It is negative infinity. Yes. Y was what?
Never mind.
You got it? All right, now if I do the limit as x goes to negative infinity, or to positive infinity now I'm really going to confuse myself. X squared minus 2x minus 3 all over 4x minus 5. That's going to be infinity. Okay, so it's not really a hard concept, which is kind of weird because you're used to writing no horizontal asymptote. All right. All right, so the book calls this power function end behavior model. It's basically saying it reduces down to an x to the first. So you look at your largest degree and for each of them and you say, okay, the new degree is going to be x to whatever. All right, so this next page. So it says find the horizontal asymptotes or end behavior of the following functions. You will need to find the limit as x goes to both positive and negative infinity. So this is what you guys will have on your homework. You'll have both positive and negative infinity. So if I have the limit as x goes to infinity of g of x, we had this on the quiz. There are actually 2 horizontal asymptotes. So think about it. If you're plugging in a big, huge number in for x, even think about like 100. If I plug in 100 in, I end up getting something close to the square root of 100, or square root of 200 over 300, right? But if I plug in a negative 100 squared, so if I make this a negative and this a negative, the top is the same, the bottom is going to be a negative. Do you see that? Okay, that's what we're talking about. So we're saying as x goes to infinity, the top is positive, the bottom is negative, sorry, the top is positive, bottom is positive. So it ends up being the square root of 2 over 3. Did anybody know that one right away? Were you like, oh, it's going to be square root of 2 over 3? All right, now this other one, if you plug in a negative number, the top is still positive because you're squaring it and then taking the square root. It's positive. The bottom will be a negative. So your answer is going to be negative root 2 over 3. So how about this next one? So limit as x goes to infinity of f of x. What do we think the limit as x goes to infinity will be? 5 over 3. What do we think the other one's going to be? Negative 5 over 3. Because if you're plugging in a big negative, that numerator is going to be negative. The denominator is still positive. All right, so this one's tricky. So I'm going to say approximately. It's like 2 absolute value of x over negative x. Okay, you're only looking at the biggest degrees, here and here. So let's think about it. So as I do the limit as x goes to infinity, think about what's happening on the top. On the top, we're getting a positive number, really big positive number, right? On the bottom, we have 6 minus infinity, really big negative number. So our answer is going to be negative 2. So this other one, when I do x goes to negative infinity, if I plug in a really big negative number, the top is still positive. Do you guys see it? Because you have the squared part under square root. The bottom is 6 minus a negative infinity. So it's 6 plus infinity. It's infinity, right? So we have positive 2. Do you guys see how I'm like logicking through these? Use logic skills. All right, so then something like this one. So we have the limit as x goes to infinity of f of x. So we're looking at the negative 2x to the 5th and the x to the 4th. Those are our biggest degrees. We pretty much ignore everything else. So when I plug in a really, really big positive number, what happens on the top? Positive or negative? Negative, right? On the bottom, positive. Which one's bigger, top or bottom? Top, because of the x to the 5th, right? So it ends up being negative infinity. So off to the side, if you needed to reduce it out and say, oh, if I have negative 2x to the 5th over x to the 4th, that's going to be like negative 2x. Think of it like that. Think of the power end function model or whatever they call it. So when I say the limit as x goes to negative infinity of f of x, what does it go to? Infinity. Does this kind of make sense? Do you get what I'm saying? Kind of weird. There's not like a lot of math behind it. It's just like thinking about it. All right, so we did this one before. So the limit as x goes to 0 of 1 over x squared. 1 over x squared ends up being symmetric around the y-axis. So if I plug in a positive number and a negative number, I get the same thing. So they both go up. So when I talk about the limit as x goes to 0, my answer is going to be infinity. Because as I trace my fingers from the left and the right and I get closer to x equals 0, I'm getting closer and closer to infinity, right? Okay, so here's the tricky thing about this, though. It says, to indicate this type of behavior, we say it goes to infinity. It indicates that from both the left and the right, our function gets larger and larger as x gets closer and closer to 0. Since both the right and the left do go to the same thing, they both go to infinity, we say that the limit is infinity. However, since it is unbounded, it doesn't actually go to an actual number, it just goes to infinity. It still does not exist. So it's kind of confusing. So your AP Calc exam, there will be a lot of questions on this in the multiple choice. And it will have, some of them will say does not exist for this answer, and some of them will say infinity. You will never have both options on the multiple choice. Like it will not say both of them. If it did, I'd probably go with the more specific one, which is infinity, right? But it won't have both of those on there. So sometimes it will be infinity, sometimes you'll write does not exist. Okay, does that make sense? Because it's unbounded, it's not going to a specific number. Okay. So there's a little definition of the infinite limits. It's just saying as you get closer to a certain a value, you go to infinity or negative infinity or whatever. Usually that's some kind of vertical asymptote, right? So number 1, so sketch a graph of the function f of x equals 4 over x minus 2. So we just talked about kind of what that graph looks like. We're going to shift right 2. And it kind of looks like 1 over x, but it's been stretched out a little bit, but it's still this way. So if you don't know that, remember you can always plug in a couple points. Like you could plug in 3 and 1, because those are on each side of the vertical asymptote, and see where it is. So as you approach 2, what is the limit as x goes to 2 of the function? What do you think? This one is a does not exist. It is only does not exist. It is not infinity. It is not negative infinity, right? Because the left and right do not go to the same thing. But the limit from the right, what's it going to be? Infinity. And limit from the left? Negative infinity. Could you also write does not exist for those? Yep, you technically could. Okay, the more specific answer, though, is infinity or negative infinity. So think about like geometry. It's really kind of a weird analogy, but geometry, you guys had parallelograms.
Yeah.
Is a square a parallelogram? Yeah, a square is a parallelogram. Do you ever call it a parallelogram? No, if possible, you usually call it a square, right? So you usually call it by the more specific name, but it doesn't mean it doesn't have all the attributes of the other one, right? I like seeing infinity or negative infinity. I feel like it's wrong. Because I'm like, it should be the, I want to know what's happening on the graph. All right, so number 2. So sketch a graph of the function with the following characteristics. So we're going to do a little rough sketch. So we're saying as we go towards 3 from the, is that right? 3 from the right, we go towards infinity. So I'm just going to draw a little arrow there, so I know I'm going up. And then as I go towards negative 2, notice how I don't have from the right or left, I just have negative 2 in general. What do I get closer to? Negative infinity. So I'm going to have going down and down there. You see what I'm saying? From both the right and left, I need to go towards negative infinity. And then I have 3 from the left goes to negative infinity. Oh, I did something wrong. You didn't notice it. Gives me to speak up. 3 from the right was infinity, right? 3 from the left is negative infinity. I saw a couple of you looking at me like I was crazy. Why didn't you say something? Bonus points, right? All right, limit as x goes to infinity is 3. Okay, so that means on the end of the graph, on the far right side, we're getting closer and closer to 3. That is a horizontal asymptote. When you say limit as x goes to infinity or limit as x goes to negative infinity. So that means we're going to a height of 3. Okay, so I'm going to go ahead and draw above. And the limit as x goes to negative infinity is also 3. So I'm going to draw that one below. All right, and then we're going to connect everything and make a function. Good? That works. All right, and the last couple, so it says limit as x goes to 3 of 2 over x minus 3 squared. We talked about 1 over x squared. We just did that one. That's the parent for this one. So can you tell what it looks like now? It's going to look like 1 over x squared, except where's the vertical asymptote? 3, right? So it's going to be shifted. Oh, I keep missing it. I did not, oh, darn. Too much of a perfectionist. All right, so we got that. So it's going to go up and like that. All right, so if we have 2 over x minus 3 squared and we take the limit as x goes to 3, what would we say? Most specific answer? Infinity. But if we have x goes to negative 2, is the parent 1 over x squared now? No, it's 1 over x. What's the negative do? It flips it over, right? So if you have negative 1 over x, negative 1 over x, instead of being like this, like 1 over x, it ends up being in the opposite quadrants. So it's going to be here and here. So that's where we're going to be for this one. So if you didn't know that, that's fine. I would just pick points close to the asymptote. So I'd pick negative 1 and plug it in. If you plug in negative 1, you get negative 3 over negative 1 plus 2, which is 1. So you'd be at a height of negative 3, which puts it below. And if you plug in like negative 3 over negative 3 plus 2 is negative 3 over negative 1. So 3, which puts you up there. So you can plug in points if you get confused on where to graph it. So what's the limit as you go towards negative 2 then? Does not exist, exactly. Good. All right. Lovely.